right. Thank you, Marcy. Hello, Cascadia JS. Welcome to this talk. How many people are feeling drowsy after lunch? Shine some light on these people right here. We want to make sure that I ask a few questions during my talk, wake people up. All right, so for the next half an hour or so, I'm going to pretend to know a few things about JavaScript. But like Marcy said, I do security research, so hopefully you'll go along with the facade and not call me out if I say something wrong. But I spend my time looking at malware, and I thought I could share some of the JavaScript malware that we've been seeing lately on the internet in the wild. So this talk is called Raiders of the JavaScript-based malware. All right, so the two important threats that I wanted to discuss is an example of a ransomware that is written entirely in JavaScript, which is something we didn't even know could happen as security researchers, because we always see ransomware written in C or C++, one of those languages, right? But this ransomware is written entirely in JavaScript. The second important thing we wanted to discuss was cryptojacking. And cryptojacking is proliferating on the internet, and we wanted to discuss a little bit about that as well. So let's go ahead and get started. A little bit about me, a little bit about our group. I work as part of the security research group at Michigan State University. Before I was a PhD candidate there, before I started my PhD there, I used to do independent penetration testing. So, finding flaws, security weaknesses for clients, and then giving them a report at the end of it so that they can fix the security holes. So I am an active speaker at security conferences. This is the first time I'm speaking at a conference which is not a security conference, so this is pretty exciting for me and a little nerve-wracking. So this slide kind of introduces some of the threats, some of the news stories that I've seen over the past week. So these are pretty recent. So ransomware is not going anywhere. Financially motivated cyber criminals love to use ransomware and cryptojacking attacks to make them money, and it's not going anywhere because it keeps making them money. So why would they, discard of this amazing method they have to make money? And what's new is the JavaScript-based ransomware that we've just seen. So the elements of a ransomware, before I go ahead and jump into the JavaScript-based ransomware called RAA ransomware, and focus on the code and the JavaScript, details of the JavaScript involved there, I want to discuss the basic elements of a ransomware. So it starts with an initial entry, right? So just like any other infection, you want to gain an entry into the host. So there's a bunch of ways to do that. I'm sure all of you are familiar with social engineering attacks. Traditional phishing emails, they have a document attached. If you get an unsuspecting user to download and double-click it, then it executes the malicious functionality on their system, right? And then there are other ways that we've seen recently which they're using, which is exploiting known vulnerabilities if you're not updating your PCs regularly. And they also love to exploit weakly secured RDP sessions or SSH sessions if you haven't got a strong password on there and that sort of thing. So the next thing they need to do is get an encryption secret, which means that, they need to have a unique key per victim. For every infection, they need to have a unique key. Why? Because you're a part of their big ransomware campaign, and if they have the same key for every victim, then once a victim pays, let's say $300 for the ransom and gets the key back, then that key can be shared with the rest of the users, and that neutralizes the entire ransomware campaign. So it's important for them to get this unique encryption secret per victim, right? And then they go ahead and start with file encryption. So they search for specific file types. They don't want to encrypt DLLs. That doesn't do them any good because you can just restore that. But what you cannot restore is your personal data, so if you don't have a backup, right? So they're looking to encrypt docx, XLSX, and that sort of thing. So they like to, finally they like to demand ransom, which is usually around $300 in cryptocurrencies. So with the understanding of the general elements of a ransomware, let's take a look at RAA ransomware. So this is the first ransomware, like I've said, that's written entirely in JavaScript. And it uses the default Windows script host. Now, I did not know that by default, Windows has the Windows script host, which is a scripting engine that executes JavaScript on Windows. So if a user, so what they do is they send a phishing email to a user, and the attachment is something like something_doc_.js. Now the users are generally trained to think that it's normally exes or executable files that are malicious, so they're more likely to download a .js file thinking that it's benign, right? So they'll download it, and then double-clicking it means that Windows script host will execute it. All right, so now they have execution capability on host. Then they use a bunch of JavaScript obfuscation tactics because in case of C and C++, the code isn't always visible. The source code is invisible to us as malware analysts. But in case of JavaScript, the source code is right there. So for that reason, they want to make it hard for us to understand what's going on. And for that reason, they use a lot of obfuscation tactics, which basically means they break anything you've learned about coding standards and good coding practices. They do the opposite of that. So it makes it difficult to read. This one likes to add insult to injury. This is not a primary functionality of a ransomware, but this one likes to also drop a Trojan in the background that spies on you and steals your information. So, no ethics in the cyber criminal, in the cyber criminal world anymore. Like, what's the world coming to? So these are what we call indicators of compromise, which means these are symptoms of an infection. In the security industry, we like to, use these as a metric towards, okay, do you have this specific infection? So a primary way to do it is to look at hashes. In this particular JS file, these are the SHA and MD5 hashes that are, that indicate that, okay, you're hit with this particular ransomware. Then you can look at dropped files. So once it executes on a system, you can see the files it drops. In this particular case, it drops st.exe, which is that pony Trojan that steals your information. So that's another indicator. And then network activity, it makes a DNS request to startwavenow.com, which is its command and control server. I'll be discussing that in a little bit, but that's where it goes to for commands. So once you execute this, what I'm going to do is I'm going to show you the system impact, and then I'll discuss the JavaScript code that leads to that system impact. So this is the process graph. Once you execute it, wscript.exe is the Windows scripting host that I was talking about. And that basically creates two processes, wordpad.exe and st.exe. st.exe is the pony Trojan that I was talking about. And wordpad.exe just puts a diversion screen in front of your face, which distracts you while it's executing malicious functionality in the background. So this is the example. This is that diversion screen that I was talking about. It's in Russian, a big surprise there. So this is an error code. They are basically telling users that this particular version of Microsoft Word or whatever cannot open this document for this reason. So while you're busy dealing with that, and while you're trying to click close, it jumps around. So when you try to get to the close button, it jumps around. So while you're trying to figure out how can I close this particular window, it executes malicious functionality in the background. And it doesn't need a lot of time to do that. A few seconds is enough. Network activity, in the meanwhile, in the meantime, network activity is something like this. It makes several DNS requests to startwavenow.com, which is its command and control server, and it's the potential source of the unique encryption key that I was talking about when I was talking about the primary elements of a ransomware. So that's where it acquires its unique encryption key from, right? But the CNC server, in case of many of these infections, the malicious domains get taken down, obviously, once they're recognized. So this particular CNC server has been taken down now, so we can't really study what response it gets back from the server anymore. But if you look at the code, so two of the things that I didn't show was it then encrypts the files. So let's say if it found your docx or your xlsx, it will then replace that with an encrypted version. And then what it will do next is, have a ransom note in every folder of your computer. So, because having a ransom note on one computer isn't enough, so it's on one folder isn't enough, so it just goes ahead and in every folder you've got on your computer, it will put a ransom note up there. So cryptojacking library is a big part of this ransomware. We've seen that ransomware developers are shit at coding. So what they do is they engage in a lot of cargo cult programming. They steal code from each other. They copy-paste code from, let's say, WikiCPP and things like that. So they already can't get many things right. So why would they want to implement crypto functionality from scratch? Because there's a lot of room for error there. So what they do is they use some kind of cryptographic library. In this particular case, they use the crypto.js library. So the first 800 lines of this ransomware contains the crypto.js code, and it's just copy-pasted. So that's where it gets its crypto functionality from. Now, the next part is the, the diversion message. So the message that I showed you on the screen on wordpad.exe in Russian, that comes from here. So if you look at this part right here, by the way, also notice the code obfuscation here. The function names and the variable names, they're very difficult to read. They're just a bunch of random characters. So that makes it hard for you to follow along with their code. So in this particular function, this variable holds a long string, which is then base64 decoded. And then it drops this particular decoded string in my documents, then creates this doc_attached_ a random string, and then puts it in front of your face by opening wordpad.exe and pasting this on there. So that's what that diversion screen was. All right, so then we talk about decrypting the pony Trojan, because like I said, st.exe pertains to the pony Trojan that spies on your information, right? So this function is responsible for creating that. And this is pretty impressive because they use JavaScript to create a binary executable file by encoding and encrypting the whole binary in string format in there. So it's hard-coded in there. So what it does is, this is a very long string, by the way. It's truncated over here, but it's a very long string which contains the entire code for pony Trojan. And then it decrypts it by using the AES encryption algorithm or decryption algorithm. And then the key for that is also encoded as part of the ransomware. And then it uses that eval command to basically get to this point. So that eval evaluates to over here. And so this is what it evaluates to, and this is what drops the pony Trojan, where it goes in the My Documents, creates that file, st.exe, which is the Trojan. And the charset 437 pertains to, it lets it figure out how to handle this executable binary data in string format. So that's what that pertains to. You'll see that throughout this ransomware's code. And then you see write text, save to file, close that file. So obviously it's creating that file now in the My Documents folder. And then finally it runs the file. So now the Trojan is executing on your computer. Next thing it needs to do is now it needs to actually perform its ransomware functionality, which is to encrypt drives. So to do that, what it does is it uses the basic object available as part of the Windows script host to go through the drives and enumerate the drive letters, and then access different files and folders, and search through the files and their extensions to know which files to encrypt and so on. So you'll see things like this, else continue, and then this is the equivalent of a goto statement, and this makes this code further complicated to understand because this makes it a spaghetti code. If they have a bunch of random goto jumps at random spots, it makes us hard to follow along the execution flow of their code. So further obfuscation tactics that they use. The ransom node comes from here, and then this pertains to encrypting the user's files, which means that this particular function right here calls this function in a loop once for every file that it wants to encrypt. So this particular function that is called in the loop within the other function will be encrypting each and every file, going through deriving functionality from the crypto.js library that I showed you in the beginning. And they use the AES encryption algorithm to do this. So a quick summary, it obviously encrypts files on the user's computer, but it also deletes VSS files. What I didn't show you for the sake of brevity is it also performs certain other tasks like deleting VSS files. These are volume shadow copies that are maintained on Windows. So you can use Windows Restore to an earlier point. So if you do that, obviously, ransomware has lost its leverage on you. So what they like to do is make sure they eliminate any backups. in any form. So because of that, they want to get rid of those VSS volume shadow copies. So it likes to do that as well. Like I said, it drops the Trojan horse, which is not really something every ransomware does, but this one does. So that's unique to this ransomware. And the Trojan is dropped in the My Documents folder. So in summary, it was very interesting for us as malware analysts to see that there's a ransomware now written entirely in JavaScript. I mean, who knew that JavaScript is a full-blown programming language, So the next threat is cryptojacking, and I want to quickly touch upon this as well because this is the second biggest thing we're seeing in 2018. So ransomware has been continuing since 2005, 2006 is when it took off, and now it's steadily growing, right? But cryptojacking took off after following the rise in the valuation of cryptocurrencies. So around the end of 2017, Bitcoin and other cryptocurrencies took off, and so of course it took other cryptocurrencies like Monero's valuation up with it, and then we are introduced to web cryptojacking. And it's the unauthorized use of processing power and electricity to mine cryptocurrency. So if you go on a website, I'll show you the web examples of this because that is more relevant to JavaScript. And so the web-based examples of this would be something like this, where you'll go on a website, and if you look through the source code, you'll see a little script being called from CoinHive is a popular source for these scripts, where they'll import the script from CoinHive, and it will initiate a CoinHive instance in the browser, and that is that unique string you see in the box is the ID of the attacker, and that is where it credits all the money. So you're basically mining for someone else while you're visiting this web page. So you can see how it can get lucrative if you have thousands and thousands of visitors visiting on your website and staying on that web page for a long amount of time. So how do you do that? You just tell them that there's like HD porn, free HD porn on this link, and people will click. It's amazing. So so here we go. So scripts as seen on the cryptojacking websites, more examples of that. This one is an example with CryptoLoot doing the same thing. So it's not just CoinHive, it's sometimes also CryptoLoot, and there's other sources as well. So what are the impact on system resources? All right, we did a little experiment just to see what they do, and this was when this threat was very new, so just the beginning of 2018. So that's the before and after shot, and before you see that the course, the computer is at normal usage, and then you visit one website, one web page, with this cryptojacking script enabled in the background, and you see that all 4 cores are now being used to 100% of their capacity, and the CPU temperature rises, and if you look at the top process is the web content that's draining 97.5% of your CPU power right now, which is kind of stupid of them because this makes it really easy to notice. But they'll get cleverer, and that's what the problem is. They're in a learning phase right now, at least as far as cryptojacking attacks are concerned. So they will figure out that it's better to mine slower and get away with it for a long duration than to do something like this, where you'll probably notice it pretty quickly because your computer slows down as well. You're draining electricity and that sort of thing. So this is more obvious. Then we see examples like this. So in this particular case, if you look at the source code of the website, you won't really see right away where the cryptojacking script is hidden. So if you're looking for CoinHive or CryptoLoot or one of those other miners, you won't really see it right away. But there's that eval function again. I recently read something about eval isn't evil, it's just misunderstood. Yeah, right. I see it in ransomware, see it in cryptojacking. So this is that eval function taken from the source code, and this is what it evaluates to. So again, as you can see, it's the same old CoinHive script that it's importing and mining on people's computer. And the problem with this is that now if you want to help by writing a crawler or something that crawls the web looking for different cryptojacking websites, and let's say that the string you put in there is look for coin hive and crypto loot and things like that. This makes it harder for you to get there because now it's hidden behind this eval statement. So how would you write that query? How would you make an automatic analysis towards if there's cryptojacking on this website or not? So that makes it a little more complicated. So I did a preliminary analysis. Basically, I was looking to crawl the internet, looking for what websites are involved in cryptojacking and that sort of thing. It didn't go very well because there's a lot of roadblocks. But what I was able to do is identify, using my automated analysis, identify 212 websites involved in cryptojacking. And what I wanted to do is resolve these categories, resolve these websites to categories, see what kind of categories are involved, more likely to get involved in cryptojacking. So if you visit a website and it's cryptojacking, is it a pornographic website, or is it already serving other kinds of malware, or what kind of website is that? So for that, I used FortiGuard. FortiGuard Web Filter categorizes websites in several categories, like pornography, and you see the examples in that little chart I'm showing. So what it does, it queries, so that little Python script on the right, it queries the FortiGuard server for a particular website. Once I've determined that this website is cryptojacking, then I resolve it to a particular category and then see how many we can find. A lot of them already are malicious websites. A lot of them are pornographic websites and that sort of thing. But there's a lot of problems, like I said, during this analysis, because how do you crawl the web? That's a big task. So for that, what I did was I utilized public www nerdy data senses. They've already got caches maintained because they already have crawlers that are crawling the internet looking for web pages, and they're looking at web pages and their source codes. So if you just query their cache, you don't have to write your own crawler, which would take forever. So okay, we can kind of get away with doing that. But how do we determine the unauthorized part during this automated analysis, right? Because there's legitimate uses of cryptocurrency mining on a web page. For example, there's an example of a website where they're asking to donate to charity by clicking on start mining and then staying on that page, and you can then donate money to charity that way. So we obviously don't want to include that under cryptojacking. So how do we determine the unauthorized part? That requires manual analysis to see if they're seeking permission from the user somewhere. So that makes it more complicated. So then how do we validate the results? Some websites are now unavailable, so some websites have cleaned their source code. So, and obfuscation, how do we get around code obfuscation? Like I showed that eval statement. So if you're just looking for coin hive or crypto loot scripts or things like that, then if they've got a clever eval statement over there, then it doesn't work that way. So maybe there's another better way of doing this that you guys can figure out. In conclusion, there's probably better ways to discover cryptojacking websites on the internet. This is not really my area to write a lot of web crawling scripts and determining. Maybe there's a better way that you guys can think of and talk to me about of doing this. And maybe we can protect our users better. So some people are coming up with browser-based extensions that automatically block all cryptocurrency mining, but they don't always work. So there's maybe some room there for improvement. And we have to stay a step ahead of the attackers, because that's what we do in the security industry. It's a constant cat and mouse game. And so we have to determine, like, this Windows script, using the Windows script host to execute a JavaScript-based malware is something we did not really see coming. So what are the other possibilities where they can use JavaScript for malicious purposes? Because if we can figure that out ahead of time, then we can maybe think about working around that. So, and like I said before, the cleverer ransomware and cryptojacking attacks are the future, where they won't mine 100%, on 100% of your CPU. They'll be more subtle. And sometimes we've seen instances where what they do is they open up, so when you go to a particular website and they're cryptojacking you, they open a window in the background, and then they make it really small, and then they hide it under the taskbar next to the clock. And so even if you close the original web page, that other web page is still open and continuously mining, and you never notice it. So until the next time you shut down your computer, that's mining for them. So they're getting more cleverer by the day. So we want to stay a step ahead of them. So yeah, if you've got any ideas, please get in touch. And this is just a quick introduction to two big problems. And I would love to talk to you more about that. So thank you very much.